Hello, fifth graders. Welcome to our next math lesson. Today we're going to take a look at lesson 5-2. It deals with estimating quotients where you have two-digit divisors. The lesson itself is going to begin on page 245, although the assignment won't be for another couple of pages after that. But 245 is where technically where the lesson begins. Now, if you remember from yesterday's lesson, we were taking a look at being able to divide numbers that are units of 10. And if you remember from our lesson from yesterday, for example, you have this problem here, we have 3,500 divided by 70. The one thing we wanted to do was we wanted to just ignore the zeros for a moment, and we wanted to just look at the division problem. And if you ignore the zeros and just look at the division problem, you should see that you have 35 divided by 7. So again, we're just going to ignore the zeros for a moment, and we're just going to divide 35 divided by 7. Or another way to look at it is, what would you multiply 7 by to get 35? Well, 7 times 5 is 35. So that must mean then that 35 divided by 7 is 5. So we're going to go ahead and write a 5 down on our piece of paper. Now we're going to go back and take a look at those zeros. And if you remember from yesterday's lesson, we want to take the number of zeros from each side and subtract them together. So for example, this side has 2 of them. So there's 2 zeros on this problem over here. This one over here, there's 1 0. So I'm going to subtract those 2. 2 minus 1 equals 1. That right there tells me how many zeros am I going to add onto my answer? Well, I'm just going to add 1 0 in my answer. So the final answer here is going to be 50. We do the same thing over here, where, again, I'm going to ignore the zeros for just a moment. And when I ignore the zeros, my division problem is just 24 divided by 4. Or another way to look at this is, what would I multiply 4 by to get 24? Well, 4 times 6 is 24. So I'm going to go ahead and write that 6 down. Okay, now I'm going to go back and take a look at the zeros. And again, I'm going to subtract the 2 sides together. So this side over here has 3 zeros. This side here has 1 0. So I'm going to go ahead and subtract those 2. 3 minus 1 equals 2. That means this right here tells me how many zeros am I going to have in my answer. So I'm going to go ahead and add 2 zeros onto this. And so my final answer over here is 600. So this was the idea that we taught in our previous lesson. And we're going to use this same information with our lesson today, except what we're going to do is we're going to round numbers first before we end up doing something like this. So this is ultimately what we're going to be doing today as well. We're going to add one more component onto that where we got to round numbers first before we get there. So on this page over here, I've got a number of examples that we're going to take a look at. And if you're very observant, you're going to notice that some of these problems, as a matter of fact, all of these problems, are going to look very familiar. I'm not going to say how they're going to look familiar, but if you're observant, you're going to see how they're going to look familiar. So I'm going to start with this first number here. This first problem here is 228. I'm going to divide that by 19. Now, the temptation is, well, this is the first number here, so let's round this number. But actually, class, what I'm going to ask you to do is actually take a look at the divisor, which is the second number. We're going to look at this number first, because I think rounding this number first is going to help us figure out how we're going to round this first number, or we may have to adjust our rounding based upon what we do with this first number. So let me tell you what I'm talking about. I'm going to take the number 19, and what I'm going to do is I'm going to round this number to the nearest tens place. So I know that the number 19 is somewhere between 10 and 20. And I got to say, which one is it closer to? Is 19 closer to 10, or is 19 closer to 20? And I'm hoping through your number sense, you're realizing that 19 is very close to 20. So this right here is actually going to round up to 20. So that's our first step. We're going to first round this divisor. So 19 is going to round to 20. Now we're going to come over to this problem here. And if you remember from yesterday's lesson, this first number here was a 2 here, so we were ignoring a 0. So what we're going to do now is we're going to round this number here to where the first 2 numbers are divisible by 20. Now this problem here is a little unique because you can round this a couple of different ways. If I take a look at this number, 228, if I round this to the nearest tens place, this would be 230, okay? And if I take a look at this, Mr. Johnson, 2 does not go into 23 evenly. And you're right, it doesn't. So what we're going to do in this particular situation is we're going to use something called compatible numbers. And what a compatible number is we're going to change the number 23 into a number that actually two can go into evenly. Because remember, we're estimating today. We're not exactly finding the exact answer today. So when we're not finding the exact answer, we do have the ability to kind of manipulate this number just a little bit, but we got to make sure that we change it to a number that's realistic. What I mean by that is I wouldn't want to change this number to like 40, because 40 is nowhere near 23. That's going to be way too high to change that number to a 40 or even a 30 for that matter. So when I go through my mathematical facts, I'm saying what number that's close to 23 can 2 go into? What number is close to 20 that 2 can go into? And right off the top of my head, I can think of two numbers. I could round it down to 220 because I know that 22 is very close to 23. I know that for a fact. Okay. So now what I'm going to do is if I decide to round that to 220, now I'm going to now just do my normal division here, where I would take 220, divide that by 20. And if I do that, now I'm going to do what I just did a minute ago, where I'm going to take, just ignore the zeros, and then how many times can 2 go into 22? Well, I know that 2 times 10 is 20. 2 times 11 is actually 22. So what I do here is I would say, well, this answer is going to be 11. Now I'll go back to the zeros. This side has 1 0. This side was 1 0. 1 minus 1 is 0, which means I'm not going to add any zeros, which means this answer would be 11. Okay. Now, some people might say, well, Mr. Johnson, okay, I could round 23 down to 22. What would happen if I were to round it up to 24? Because I also know that 2 can also go to 24. And, you could do that. What I could do is erase this, and I'm going to erase this number right here, okay? And what I'm going to do is say, rather than round this to 230, I'm actually going to change it to 240. And again, the reason why I'm changing it from 23 to 24 is only because I'm trying to find a number that 2 can go into it without having any remainders whatsoever. Now, there might be some people say, Mr. Johnson, I wanted to do 240. And if you wanted to do that, you could. You technically could. And you're perfectly acceptable to do that. And now what I would do is say, how many times can 2 go into 24? Well, I remember from my previous problem that 2 can go into 22, I think it was 11 times. So if I add one more on that, which is 12, then 2 can go into 24 12 times. And again, this side has 1 0, this side has 1 0. So I'd say that my answer is just 12. So either one of those answers would work just fine, okay? Now, not all of your problems are going to be like this where you can change it from one to another. Most of the problems you're going to have today, it's pretty clear as to how we're going to change the number. And then I think the rest of the problems that are on our page here will help us kind of figure that out. Okay, so for example, let's come over to this problem over here. We have 1,784, and I want to divide that by 64. Now remember, the first thing I want to do is round this divisor. I'm not going to round this number quite yet, okay? Because I want to round this number first. I think divisor is the most important part. So we're going to take 64, and we're going to round that to the nearest tens place. And I know that 64 lies somewhere between 60 and 70. So I got to say, which one of these, is 64 closer to 60 or 64 closer to 70? And I hope you realize that 4 tells me that it's going to round down. So I'm going to round the 64 down to a 60. That's my first step. Let's round this down to 60. Now let's come over here. And since I'm talking about 6, what I want to do is just look at the first 2 numbers, okay? Can 6 go into 17? And of course it can't. But is there a number that's really close to 17 that this number 6 here can actually go into? Well, if I do my multiplications of 6, 6 times 1 is 6, 6 times 2 is 12. Well, 12 is kind of close. But if I go 6 times 3 is 18. And 18 is really close to 17. So what I'm going to do right now is I'm going to change this number here to 1,800. I'm changing the 17 to an 18. And then everything else behind it, this 8 and a 4, we're just going to automatically change those to zeros. Okay, kind of like over here, we changed the 22 to a 23, right? And then we just made the 8 a 0. So everything else behind it is going to automatically become zeros. Now, my new problem is 1,800 divided by 60. So again, I'm going to ignore the zeros for a moment, and I'm going to take 18 divided by 6. 18 divided by 6 is going to be 3. Okay, now let's go back to the zeros. This side has 2 zeros. This side has 1 0. If I take 2 minus 1, 2 minus 1 is 1. That means I do need to add 1 0 onto my answer. And so we would say that estimating wise, this would be about 30. Remember, we're not finding the exact answer today, boys and girls. We're just trying to find a number that's close. It's rounding, it's estimating, okay? Let's do the same thing with this problem down here. I have 7,260. I'm going to divide that by 83. Again, the first thing I want to do is round the 83. Okay. And does 83, do you think that's going to round down to 80? Or do you think that's going to round up to 90? I hope you understand that this would actually round down to 80 because this 3 here tells you that that 8 is going to stay the same. So I'm going to round this to 80. And that's pretty important for me to do because now what I'm going to do over here is I'm going to underline just the first 2 numbers. And I'm going to say, can 8 actually go into 72? I know some of us aren't the greatest at our multiplications of 8, but I will tell you that 8 times 9 is exactly 72, which means I don't want to change this. So I'm going to keep the 7 and the 2 the same, and then everything else behind it is going to become zeros. That 6 and that 0 are going to become 0, 0. So now I'm left with this new problem, 7,200 divided by 80. Again, ignore the zeros. Kind of like we did in our lesson from last time. Ignore the zeros, and 8 times 9 is 72. So I would say that the 9 is going to be there. That's important. Now let's come back to the zeros. 2 zeros on this side, 1 0 on this side. 2 minus 1 is 1, which means the answer is going to be 90. Okay. Over here, same idea here is, okay, I have 12. This is the first number I want to take a look at. If I round that to the nearest tens place, what would 12 round to? Is it going to round down to 10? Or is it going to round up to 20? And I think it's going to round down to 10 because I think it's closer to 10. That 2 tells me that that 1 stays the same, so it's going to be a 10. Okay, now what I'm going to do is I'm just going to underline the first 2 numbers over here. Okay, and can 10 go into 22? And I hope you realize that it can't. Now, is there a number, this is where we're going to use the idea of compatible numbers. Is there a number that's close to 22 that 10 can actually go into with having 0 remainders whatsoever? Well, I think 20 is our best option. Some people might say 30, but I think 30 is a little too far. I think that's 8 digits away. But if I round this down to 20, it's only 2 digits away. I think 20 is a closer answer. So I'm going to change the 22 to a 20. And now everything else behind it, the 8 and the 0, those are also going to become zeros as well. So now I'm left with this division problem. I have my zeros. I'm going to ignore the zeros. By doing that, my division problem is, what is 2 divided by 1? Or another way to look at it is, what number would I multiply 1 by to get 2? I hope you realize that that answer is 2. Now let's go back to the zeros. There's 3 zeros on this side. There's 1 0 on this side. 3 minus 1 is 2, which means my answer is going to have 2 zeros on it. So this final answer here is going to be 200. We're going to do a few more problems on this slide over here. Again, the same idea here is we want to round the numbers. We're going to round the divisor first. And then once we round this divisor, then we're going to be able to round this number here to a more compatible number, a number that can actually go in there evenly without having any remainders whatsoever. So if we take a look at these problems here, 92. If I round this to the nearest tens place, I hope you would realize that this is actually going to round down to 90. It's actually closer to 90 than it is to 100. Now, with that in mind, I'm going to underline the first 2 numbers on this problem here. Can 9 go into 48? If we do our multiplication facts of 9, I don't think there's anything that 9, you can't multiply anything times 9 to equal 48, all right? So now we got to say to ourselves, okay, is there some number that's close to 48 that 9 can actually go into? Well, if we do our multiplication facts, I think 9 times 5 is 45, and 45 is really close to 48. So I'm going to change this 48 to a 45. And now this 5 behind it, that just becomes a 0. And now this is my new division problem. And now this looks like something we just did the other day. How many times can 9 go into 45? 9 can go into 45 5 times. So we're going to put a 5 here as my answer. Now take a look at the zeros. 1 0, 1 0, 1 minus 1 is 0, which means I'm not going to add any zeros whatsoever. So the final answer for this problem is going to be 5. Over here, take 61. If we round 61 to the nearest tens place, this is going to be 60. Okay. Now what we're going to do is we're going to take a look at the first numbers here, because I want to say, how many times can 6 go into 54? Well, you know what? It just so happens, class, that 6 times 9 is exactly 54, which means we don't have to change this number at all. That's kind of a nice thing. So this is going to stay 54, and that 0 is already a 0. So, you know, we didn't even have to change that number at all. The only thing we did is we changed the 61 to a 60. Now we're just going to look at the non-zeros here. 54 divided by 6. Well, I just mentioned a minute ago that 9 times 6 is 54, so I'm going to go ahead and put a 9 here. This side has 1 0. This side has 1 0. 1 minus 1 is 0, which means I'm not going to add any zeros whatsoever to my answer. So the answer is going to be 9. We got 2 more problems over here to do. Here we got 32. If I round 32 to the nearest tens place, this is the first rounding I want to do right here. 32 is going to round down to 30. I think it's closer to 30 than it is to 40. So now what I'm going to do is I'm just going to underline the first 2 numbers here. I'm going to take a look at this 3 here. Can 3 actually go into 17? Now, I don't think there's anything I can multiply 3 by to get 17. So then I say, okay, is there some number that I can multiply 3 by that's really close to 17? Well, I know that 3 times 5 is 15, so I could possibly change it to a 15. But I also know that 3 times 6 is 18. And so between 15 and 18, which one is actually closer to 17? I think the 18 is actually a little bit closer. I think it's just 1 digit away as opposed to this one's 2. Although they are both pretty close to each other, I think I'd choose the 18 because 17 is obviously closer to 18. So I'm going to change the 17 to an 18, and then the rest of the stuff behind it just becomes zeros. And now here is my new division problem. How many times can 3 go into 18? Well, I think 3 times 6 is 18, so I'm going to go ahead and put a 6 there. And now I'm going to take out my zeros. There's 2 zeros on this side. There's 1 0 on this side. 2 minus 1 is 1, which means I do need to add 1 0. So the final answer here is going to be 60. Let's do our last problem on this particular sheet here. I'm going to take 67 here. Now this time 67, I think I'm going to round this one up to 70 because I think this one is closer to 70 than it is to 60. So I'm going to go ahead and round 67 up to 70. Now, again, I'm just going to underline the first 2 numbers on this side over here, and I'm going to take a look at the 7. Is there some number that I can multiply 7 by to get to 27? Well, I don't think there is. So now I got to use compatible numbers. I'm going to change it just a little bit. Is there some number that I can multiply 7 by that's really close to 27? Well, 7 times 3 is 21, and 7 times 4 is 28. And I think between these 2 numbers here, I think I want to change it to a 28 because 28 is obviously closer to 27 than 21 is. So I'm going to change the 27 to a 28. And now everything else behind it becomes zeros. And now this is my new division problem. All right. So how many times can 7 go into 28? 7 can go into 28 4 times. So I'm going to put a 4 there. Now I have 2 zeros on this side. I have 1 0 on this side. 2 minus 1 is 1, which means I do need to add 1 0 into my answer. So that final answer there is going to be 40. So fifth graders, I'm hoping you're seeing that the half of this assignment is exactly like the assignment we did from the last lesson. The thing you have to do is you got to change these numbers to these division problems here, and which means you may have to use something called compatible numbers. You may have to change this first number just a little bit. But the important thing I think fifth graders for you guys to understand is you have to change this divisor first. Change this divisor first before you start rounding this. Okay, because once you know what this number is, that'll help you narrow down what number you're going to change this one to. All right, so if you take a look at your assignment for today, again, there's going to be no word problems in our assignment for today. It's going to be over two pages. You have page 247, and you're going to do numbers 11 through 22 on that particular page. Again, all of them are just rounding and then finding the answer, no word problems. Then if you go on page 249, you're going to have a few problems to do on that page too. That's numbers 4 through 15. Okay, so if anytime you get stuck on any of the problems, you don't know what to round it to, whatever, don't hesitate at all to please ask me for some help and assistance. I will gladly do that for you. I hope you guys do well on the assignment for today. If you need to watch this video again to kind of help you understand a little bit more, please feel free to watch as many times as you like. But if not, we will see you with the next video.